Zip9 Hub.
Hello, welcome to another series of Zip9 Hub. In this set of presentations, I will be showing you how I use a mathematical program called the graph calculator. I mainly use this. First, it's because it's a freeware, you don't have to pay for it. And it's really easy for me to use it, especially when I want to check the graph of some functions or relations very fast. And also, I use this one when I have to prepare materials, for example, handouts or modules for my students. I find I find the output of this program better, and since it's a program, I can save it as a graph file so that later on, if I have to edit it, then I will just go to the file and do the editing, and I do not have to be starting from scratch. So okay, so I'm going to introduce to you to the graph software. You are in your internet. Just type download graph, and actually the first thing that comes out is what we want. So download graph. If you click on this one, we have the setup file. So just click on the setup graph. The version is 4.4.2. Just click that one so we can download it. There it is. It's downloading. So just wait for a moment to download and then go to your download files. The installation is very straightforward. Anyway, I already installed this one in my PC, so I do not have to wait for the download and install it again. Actually, I pinned it already on my taskbar, so if you can see this one, this is the graph calculator that I was talking about. Let me close this up first. If you open this program, it would look like this, the interface of this program. So it's really simple. You can see here partition plane, because the main purpose of this program is to graph functions or relations. So I'm going to guide you through it. So the most important part of this program I'm going to show you. So let's start with our partition plane. We have, of course, the two axes here, the x and the y axis. Actually, we can edit this one here, this button here at the uh, left top of the how do you call this, the window. So if we click this one, we can see here how else can we edit our axis. So you can change the scaling. So it's by default the scaling is 1, but we can change that one. So if we want to change it, uh, if we want to change the scaling by say 10 units per scale or per grid, then we can do that. So for example, we change the scaling of the x-axis to 10. It would look like this. So there we have it, the scaling in our x-axis thing. But I do not want that one. So let's go back to 1. So it should be 1. Also, if you are working with trigonometric functions, so that the x-axis must have to be angles in radians, we can actually do this one. So show, we can click show as a multiple of pi, so that our x-axis would then look like this. this so the numbers in our x-axis are angles in radians. Anyway, we can move the Cartesian plane by clicking this hand button here. So if I click this one, I can actually move the Cartesian plane anywhere else I would like it to be. So there we have it. We also have the zoom buttons here. So if you want to zoom out, you can click this one. or I can scroll in or out. So it would zoom in or out the partition plane. Those are the buttons that we have to use if we want to zoom or to move our partition. I'm going back to the default setting. So I want to stick with numbers, not angles and radians. So I'm going to remove this one. And that's it. Actually, we can do the same for the y-axis. So this is the setting for the x-axis, and this is also the setting for the y. What else do we have here? We can show legend. So later we will be graphing. And if you want to show the legend, meaning the name of those graphs, we can do that. By default, it's already checked. So it will show in our main window the legends. Fonts in colors, it is referring to the font in color of the numbers on your axis. So if you want to change it, then you can do it here. By default, the background is white. That's why we can see here that majority of the interface of this program is white. If you want to change it to some colors, you can do that. Of course, we choose the colors based on what we think is best for ourselves and for our audience. Normally, those are our students. Okay, we can actually put grids, so it looks like a graphing paper, our partition plane. But for now, I do not want that. So I'm going to do the changes on yes. So by default, the partition plane looks like this. Okay, let us try to graph a function. Let's start with functions. And where can we do that? What button should we click for us to encode a function? Is here. This button here, it's just beside the access button. It's the add function button. So if we click this one, it will give us a pop-up menu asking what function should we want to graph. Okay, so I have prepared here some functions for us to encode. So where are my functions? Let's try to look at the functions I have prepared here. Let's start with our polynomial functions. I prepared a polynomial in rational. I prepared four functions, one for linear, one for quadratic, one for cubic, and another one for irrational function. So of course, I'm not going to discuss what are these. These are functions, but I'm not going to define what a function is. We are just trying to learn how to encode or to use the graph software, the graph program. So how should we input the first function here, x plus 1, f of x equal to x plus 1? Actually, it's very straightforward. We just encode as is. So here, the left part of the function is already built in. It's already here. So we do not have to encode f of x. So f of x is equal to, we can encode directly the right part of that equation. So that's x plus 1. So we simply write it x plus 1. What are these bars? If we want to restrict our function, we can do it here. So if we want to show a portion of the graph and not the entire graph, we can do it here. But I'd like to show you first how it looks like if we do not put anything here, if we do not change this one. Well, of course, that is a linear function. So what should we expect? It should be a line. The graph should be a line. There we have it, the line. This is the legend that I was talking about a while back at the right top part of the interface of the window. So it's f of x equal to x plus 1. If we want to remove this one, we do not want it, then we can uncheck show legend here. So just right click on it and then uncheck. Okay, let's go back to the setting. So I can go back to the setting by double clicking the function here. So I am here, double click it, and it will again show us this pop-up window. So I want to restrict the graph from -2. So I'm going to type here -2 until +3. This is just an example. how should we want our graph to start and end? So we can change it here. So since we want to show that the graph is extending indefinitely, we may want to use arrowheads. But if we want to show an interval, just really a part of the graph, then we can use what are these points, circles. So if it's included, if the endpoints are included, we have the shaded points and then unshaded for if the endpoints are not included in the set. For now, I want this one, the arrowheads. I'm going to do the same with the end. That's it. And then a description. Sometimes if we are encoding a lot of functions, we may want to change the names of the other functions so not to confuse ourselves and our students. So later on, we're going to change the name for some other functions that we will encode later. Line style, that's the reason why the line is broken, because by default it's broken. So we can change that by a continuous line by clicking it here, arrow down, and then choose what we want. The color is what is this? Purple. I don't want purple. I want to start with the okay, black. Let's start with black. Width is pertaining to the line. How thick would you like your line to be? So I am okay with 2. So this is my graph. That's it, our first function. Let us graph the other 3 functions here. X squared minus 2x plus 5. So again, let me click on the add function button and then encode this one, x squared minus 2x plus 5. So we have x squared minus 2x plus 5. Of course, our power function here is represented by this symbol. So we do not really have exactly the same syntax with how I encoded the functions in this PowerPoint presentation. Anyway, it's how the graph software interprets power. So it's a quadratic function. You should expect a how do you call this? We should expect a parabola. So there we have it, our parabola. Let me restrict the function again, just like we did a while back, so that we can see its end. So maybe I'd like to start with negative 0.2 until 2.5. I want a different color, so just to differentiate it from the other functions, this time I'm going to choose red, and then I do not want my second function to be named as f of x again, so I would like to change this one under this bar. So legend text description. So I want to name it g of x, and then just click OK. Let's see if our graph is okay. Yeah. Those are the 2 graphs that we just encoded. So if you notice the red here under our legend, the red line here is represented by g of x, and that's correct. Another one, we have a cubic function, very simple, h of x equal to x cubed. So just the same, click on add function and then encode our function. So that's x raised to 3. How does it look like? It looks like that. So let me edit it again. I want to start from negative 1 until positive 1.5. Let me be okay. Endpoints are arrowheads, and the color is different from black and red. And I want to choose blue. And that's it. Our third function, and then of course the last one, our rational function, 1 over x plus 1, and we want to name that as p of x, 1 over x add function. So we encode 1, start with 1, divided by, so that's just a slash. We, to avoid confusion, we enclose the denominator with a parenthesis. That's x plus 1. How does it look like? It looks complicated. Let's edit it further so it would be unique from the other graphs. So let me start. Let us start with this one. I want to start from -6, maybe -6 to +6 arrowheads, and change color, and maybe this one. So there we have it, our 4 functions. 3 are polynomial functions, and the last one is a rational function. Oh, we did not change the name of x cubed. That should be h of x. So we go back to our description and then change it to h of x. No problem. And then we do the same for the last one. It can't be f of x because we have an f of x. We have a function named f of x already. We want this to be p of x. So there we have it, the functions that we want to graph. So whether you are checking on the function or you are preparing for a material, I think this is very easy to use. We do not want to use the legend, and we want the labels to be near the functions. We can actually do that. So we can do that by adding a label. This button here, capital letter A, is a button for us to add label anywhere on our partition plane. So let's click on it. It will give us another pop-up menu. This is where we can put our label. So we want to label it. So for example, I want to label my first function named f of x. Let me do that. I want it bigger, so I can adjust the font size. 28 maybe. We can choose if we want to make our label bold or italicized. I prefer italicized. So that, I think I'm okay. We can change the font style. I am okay with Times New Roman. So there we have it. Anyway, we cannot move the label if this is checked. So we uncheck this one, and then the cursor becomes like this. It's like 2 perpendicular lines with arrowheads. I want to make this closer to the graph. So labels. This is what labels do. Let's do the same for the other functions maybe. So let's click it again here. This time the name is g of x, in the color for that graph is red. So I may want to change the color of the text to red. So there we have it, g of x. Just put it beside this one. What else? We have h of x. Color blue. And of course the last one, is p of x, and that's color, whatever color is this, pink, purple, yeah. Alright, those are my 4 functions. Now what else can we do? In the right, or I mean in the left part of our window, we can see everything here, every functions or every actions that we've been doing. If it's checked, then it will show here. So if we uncheck these ones, then it will not show. So for example, I do not want my labels, I will simply uncheck it here. If I don't want some of the functions, then I will uncheck it here, so that only the first function will show. What else can we do? What buttons can we see here? this button here is a way for us to encode or to input a point. Let us click on it and it will give us a very simple table. This is where we put the coordinates of those points that uh, we want to graph. So I have here prepared some points. Let us graph them. So the first point is 2, 3. The second is negative 1, 8. Let me write it here so we won't forget. We have 2, 3, negative 1 over 8, 1 half, and then 1 over 8. And then the last one is negative 5, negative 1, 4. So actually we can encode these 4 points simultaneously here. So the first point, the x coordinate is 3, the y coordinate is 3. I mean the x coordinate is 2. And then for the second point, it will automatically create a new row. This is where we put our second point, negative 1 and 8. For the third point, we have 1 half or 1 over 2. The y coordinate is 1 over. And then we have negative 5, negative 1, 4. If we want our points to be of different colors, we can do that. What colors do we want? Maybe we want the basic one. I'll go back to black. If we want your points to be of bigger size, then we can increase the width. So let us use 2. We do not want to do linear interpolation. Linear interpolation means to put some points in between, to estimate a point in between linearly. If we want to show the coordinates, meaning these coordinates around those points, then we can click this one. So let's do that one. Do you want the coordinates to be below the points, or to the left, to the right, above left, above right? We have a lot of options. It's up to you to choose. I'd like below. So this is how our point looks like. So I'm going to change this one to black also. So those are the points that we want our graph to plot. So those are the points that we just plotted. So the 4 points. Let me check again the 4 graphs. So actually, each of the points here are points on one of the graphs of the functions that we just got. So there we have it. What else can we do here? We can put shadings. This button here, this one, it looks like a mountain with shades. That is where we can put shades under or above one of our functions. So let us remove some of this one so that it will not be very busy for us to work with. I'd like to stick first with our quadratic function, our parabola. What if, just what if, we want to shade, to put a shade below the graph. So for some reasons, we want to show this one. We can do that here. Just click on the functions or function where the shades, where we want the shade to be applied on, and then click on that button here. And then it will ask us some options here. If we want it below, then we click it here. If we want it above, we click it here. Let's try below the function. So there we have it. Shades below the function. Of course, we already restricted this one, so it will only give shades on under this portion. What else can we do with this software? It can actually calculate table of values. How about that? This one. So let's remove the shade and click on the function. If we click on this one, this table here, this button here, it gives us another pop-up menu asking us from what interval we want to make a table of values. So we start with -10. By default, it's -10 to 10. That's too long. Maybe we can start with -2 and then stop with +2 so that it won't give us a table that is very long. Okay. Delta x, that's the increment of change. 0.1 is a lot, so this means -2, -1.9, -1 point. So we want only the integers. So maybe we can change this one to 1. And then if we click this button here, calculate, it will give us a value. And look at that. It's not only the value of the function at -2, -1, 0, 1, 2. It also gives us the value of the derivatives on those x values. Also, we have the second order derivatives. So these are the derivatives. F prime of x represents the derivative, the first order derivative. F double prime of x represents the second order derivative. So I hope you can still remember what derivatives mean. So since we made delta x equal to 1, it only started from -2, and then we have -1, so the integers. But if we go back to 0.1, then it will give us tables of values by that increment also. As I have said, it's a long picture there. So it's table of values. Let's close this one, right? How do we save a file from the software? Just go to File, and then we can save it as a graph file. So this is very important if you want to save your work. So let's check all. So it would show the work that we have done here. We want to save it first as a graph file. What's the importance of doing that? If we want to change our mind, something on the graph, then we can do that because we saved it as a graph file. We can open it again in this program. Because if you save it directly as an image, not saving it first as a graph file, then you cannot edit this one because it would save it as an image file. So it's safer to save it first as a graph file. So if you click that save as, just like saving any file, it will give us this window. There's only one file type that's available, the graph file, grf file. We simply have to name this one. So let me name this one as sample and save it to a folder that we want to save this file. So just in my desktop, I haven't prepared any, and then save. Alright. Now we are done saving this one as a graph file. We can now proceed saving it as an image if we want to include this one in our material. So save as, and then the options here, the different file types that we can use. We have the PNG. So I think this is the best image file that is available here. We can also save it as a PDF. I'd like to save it as a PNG file, also in my desktop. So let us do that, and then open it so we can check. So we have it here. So here is the graph file that I have saved. This is the image that I have saved. There we have it, our image, the saved output from the graph software. So we can use this one in our materials already. Alright, that's the end of our first presentation on using graph. I will see you in the next video for another tips and another example, another set of examples of graphing in this software. I'll see you there.